All right. So today what we're going to do is just a bit of a course overview and take a look at the first half of week one stuff. So the class is laid out just like this on FSO. We have course materials and policies. This class layout should look pretty similar to the PGF2 class you had before with me. On that, my name's Justin Murphy. For those of you that don't remember me or don't recognize my voice or photo and stuff from the PGF2 class. I'll be your main course instructor for the rest of this month, along with Sean Paris or Sean Lockhart, maybe helping out during lab. So without further ado, let's get into these materials. Course materials and policies. Make sure you do download Unity. As far as the version, as long as it's the latest that is not alpha or beta, and a minimum version of 2019.1. So if you have a newer version than that, it's totally cool. I'll be working off of the newest version that as of yesterday was 2019.3.12 F1. So you can use whatever your latest version is, just make sure not an alpha or beta version. As far as the course materials, there is another Google Drive link for this right here. And this lays it out similar to the other, the actual FSO layout, where we have the policies, week 1, 2, 3, all broken down for what you should be working on during that week. Then we have a common problems document, which is currently a work in progress. As we notice more and more issues that might seem common, we will add them there. So I do recommend checking that out just in case. It goes over a couple of things that help out, but we'll flesh that out as the month goes on. A link to the live sessions, which you're currently in. So hopefully you were able to find that either through Discord or right in here. A link to recorded lectures. So the recorded lectures is a playlist of previously recorded month's content. So this first one is basically the lecture we're going over right now. The next one will be for your next assignment, and they are all named based off of the actual assignment themselves. If you do actually open one of them up, in the description will be a more accurate description of what that's actually going to go over. So I do recommend checking those out. If you do miss one of the lectures, all these Zoom live lectures will be added towards the bottom of this list right here in the same playlist. So everything will be right here through the recorded lectures if you ever need access. And as I mentioned, each session will be recorded and they'll be uploaded to that same playlist just for a reference. So don't worry if you can't make it to every session or something like that. As far as the Discord support, we have that channel up. I know there's a few that weren't quite added until after Monday because they'd updated the rosters pretty late on Monday. So I've updated it again, so now everybody in our class has been added. If you're not aware of the Copilot Tutoring Center, it's a great offer to try and help out, try and get you some additional help if you're really struggling with a certain course. They'll try and find a compatible tutor for you. So that's course materials and policies. Now the intro assignments. Intro assignments, professionalism, course overview, instructor contact info. They're all pretty straightforward. As far as the course overview, so this course is called Game Development. What does that mean? Well, that's a very broad term, and we've just been treating the class similar to like a Programming Foundations 3. So you will be focused on programming and actually getting projects working through scripting, and not so focused on any of the aesthetics or anything like that, but you will be working on projects throughout this course. A couple of the topics that we're going to cover, and I might as well open that up. just so it's not the same screen over and over. A couple of the assignments, this just kind of explains how to submit for the different assignments. I'll go into the assignments themselves. This very first week, the first half of it is mostly a review along with introducing a new data structure called dictionaries. So some of you may have worked with dictionaries before, some of you may have not, but we'll go into that a little bit more once we start reviewing the basics and things. And then we start working with the navigation system. So we'll be working in navigation system, getting a little bit of taste of that towards the end of this week, as well as state machines. So the state pattern itself is a way to structure your code to solve a problem that many programmers have seen over the years, and it's become what is called a pattern. It's noticed issues, so there's some solutions that we can get around those issues to try and simplify our code down and keep things more modular. So that's week one. Week two, we'll also start off kind of slow. We'll be doing some intermediate scripting stuff, taking a look at inheritance, some more advanced topics such as interfaces, things like that, to brush up your skills a little bit more, along with some more thought process on the state machines themselves. So we're really pushing a heavy thought first approach to this, where we're explaining those topics in detail by theory. And then we take a look at actual implementation. So like we actually start adding the state machine to code itself down here. While examples may have been shown in the previous assignments and things like that to give you a taste of it or how things could be set up, this is where you'll actually be adding a state machine to your code and actually getting your hands on with it a little bit more. For week three, here's where we've been going over a couple of weeks now with navigation agents, and this one also introduces a manager so we can interact with those agents just one at a time. And finally, we get to our sneaky project. So this project is a culmination of everything you've slowly been introduced to throughout the month. It's going to put to work the navigation system, along with the state machine, along with actually having these objects interact with each other, being able to interact with the objects and put an actual game together. So we're creating a stealth type game, an avoidance game, where you'll actually be sneaking through the level. And I might as well just give you a little bit of a preview of an example. And let's go sneaky. Hopefully this is the right one. Just to give you an idea of what you can look forward to towards the end of the class. Yep. So in here, we have our player indicated by this little cylinder over here, and our agents themselves are these other teal cylinders. As we're playing, we will actually be using the navigation system to get our character to move around. So like if I click on the other side of this wall, rather than going straight to that point, it'll navigate around that wall, stuff like that. Same as with our nav agents. They'll be cycling through some certain states. You'll see their colors change as they're in different states and things like that. And the goal of this is for you, the player, to sneak past all the guards. So I just got, oh, and the camera's screwed up in this one. Dang it. Well, that's unfortunate. But to sneak past all the guards, and there's 4 different rooms all set up, and the goal is to get to like an end point, and then that's considered you escaping. You can also individually select the guards and stuff like that. So while I'm playing, I'm going to just take a look over at this view, and we've selected that guard up top. And then we can issue it certain commands. We can actually pause them, start them up again. We can also tell them to reverse their navigation the way they're going through their nav points. And we can issue a command as like a distract technique, like we set off an alarm over there at the wall, and the guard has to go inspect it. And think of this like throwing a rock. If you've ever played like Assassin's Creed or something like that, you have like the, I believe, rocks or coins that you can throw to get that guard to hear that noise and go over to them. As we saw earlier, if we do approach one of these guards, it will aggro them. So the guards will be alerted to your presence and start chasing you. After a certain amount of time or a certain distance away from that guard, they'll stop and just go back to their normal states. So it really reinforces how we're switching states, what each state does, and how to interact with things that are running a state machine. So beyond that, for week 4, so a little bit of ways, but might as well just brief you on what to expect. Week 4 is all about animation system, going a little bit more in depth into the animation system than you have in previous courses. Rather than just playing a single animation state at the time, we're going to look at the blending so that we can have a direction, speed, all actually smooth using the Mechanim system. On that, we also take a look at how the physics system works with the animation system. Because as you get more and more complex, it may be great to have an animation set up, but if you don't have physics or that character needed physics associated with it based on the animations, things can get a little wonky. So you'll have to really look into those systems a bit more rather than just say, yep, I want physics on this, or I don't want physics on that. It becomes a learned skill the more and more you work with it. So that's about it for the general course content. Are there any questions about anything so far, or class layout, what to expect?
Got nothing.
Nothing? Alrighty then. Let's move into some basics review. So
Yeah. Is there any chance you could extend the due date for the experiment, the dictionary?
yeah, I'm gonna do the some basic stuff, and then we'll take a look at dictionaries.
Yeah, because the due date already passed, and
Yep, and I'll be extending that since normally I do that on Monday.
all right.
So, yep, I'll take care of that just after this session because I have 3 different sections that I'll have to go through and extend the dates on.
Appreciate it. Thank you.
No problem. So these experiments, we'll just kind of walk you through a couple of things of how to get some basic scripting working. This one even has an example for you, but we're just going to take a look directly in Unity itself. So you're not seeing the same content over and over.
Okay, I did that. Download the experiment itself and put it on Unity.
Yeah. That's the intention of this one. I'm not going to do the experiment with you because that is something that you should just work through on your own. But I'm going to go over the same kind of topics that they cover just to make sure that you understand the basics. So we're in Unity and we need to get some basic things in here. First thing I generally do whenever I get an empty scene from Unity is always add some sort of floor, whether it's a cube, whether it's a plane. We'll go with plane. Next thing I immediately do is jump to our trusty friend Google and look for some sort of checkerboard texture. Once you see one, and yeah, we'll go with this. We can go ahead and download that. Save image as. And you wouldn't typically just download something straight from Google if you're using it in a released project or anything like that. But since this is just for demonstration purposes, I don't intend to make any money off this or anything. I will just be using it for my own purposes to make sure that the grid is laid out correctly. So this gives us a little bit of a better backdrop to actually see our things moving around. And next up, there's a few things about scripts. So we can go ahead and just create a basic script to take a look at some of the basics. So we technically didn't need a floor or anything to run any scripts, but I always like to add one just because it makes the scene have anything in it other than the camera. And we'll go ahead and call this basics. All right, so we've got our script. A couple of things I want to just talk about, as if you like never saw a script before. We have these using statements up here. These are actually telling it which parts or which modules to import or which namespaces to use to give us access to different things. You will notice Unity Engine is white, whereas the systems collections and system collections generic are both grayed out right now. That just means we are using something from this namespace. The other ones are unnecessary. So this class will have you actually use the IDE or integrated development editor or environment, which is also just referring to Visual Studio. Hovering over gives you a lot of very useful things. It'll even try and show you different potential fixes for certain things. The one thing I do want to point out is Unity Engine is currently being used for this script. And that comes from this base class right here. We're actually created a script, and it's created a class called basics. It's automatically saying it wants to inherit from mono behavior. So if we did want to inherit from something else, we can always change that right here. Just keeping in mind when we are going over the intermediate topics next week, we'll be talking about that a lot more. It automatically gives us two functions. We have a start function right here and an update function. They have comments as well, just explaining when each one of them is called or when that code runs. So typically, to declare a variable, if we have int I, this is what is called declaring. Declare. If we have int and we can't use the same name twice, int n equals 3, we've now done what is called either a definition or declaration and assignment. So that actually is just a couple of terminologies that you should remember back from PGF1. I know PGF1 was quite a while ago, so I just wanted to remind you on, like, if we're looking for a declaration, it's just where that int is declared or function is declared. It's not where it's defined. It has no value yet, or we'll just use the default value. If we wanted to see this on the screen, we can use what is called debug print. You'll notice I added this print down in the start function. or not print, debug log, sorry, jumping back and forth between engines too much. So debug log is how you print it to the console in Unity. We have to do this inside a function. We can't call a function just inside the class itself. Visual Studio will complain. So it's saying debug log doesn't even exist because we're not actually in any of the functions. So we do want that inside one of our functions that we wrote or any of them that we started with. And that's how we can print the value of that. So we have this in start, which means it's going to be called before the first update. If we try and take a look at this, and I'm going to close out of that one so don't keep popping back to it. Here we have our basics. If we just play now and have our console open, we're not getting any prints. Problem is, I created the script, but I never added it to our level or our scene. I would have to attach the script to something in the scene for it to play. It could be literally anything that I want, since this script doesn't really care about the game object itself.
Like the plane?
What's that?
Like the plane you just built?
Yeah, I could attach it to the plane. I did actually just end up dropping it on the camera. So our camera now has the script called basics attached to it, and we can add even more scripts to it. Just a reminder that script is a component that can be attached to any game object. So we press play now, and we do get a print saying 3. When you are in here, if we wanted to see where that decided to print at or where that code is, down in this bottom section here, we can actually see the exact line it was printed on and click on that to bring us to the exact log or spot where it's happening. So that comes in real handy when you're trying to track down if you have a bunch of prints named the same thing or trying to find an error. Be sure to use those links built in. And let me hide these again. There we go. So if we wanted to modify the value of that integer, n is actually starting out at 3 when we first define it. And then we can go ahead and say n, if we wanted to change its value, let's say I wanted it to be 6. We can just say equals 6. This is the assignment operator again. There's a lot of different assignment operators that you'll be using throughout the course of this class. There's even n++, which is an increment operator, adds 1 to itself. N-, subtracts 1. And so on. There's then also n plus equals or minus equals. All those different operators, multiply equals, can all be done on it. You could even just have an equals and say n equals n plus 1. And that's literally the same thing as the line on 17. So keep in mind there's a lot of different ways to write the same kind of code. You just need to find one that works for your situation. So n should be 6 now before the log. If we changed it after the log, let's say we're going to multiply it by 5. And with that, we'll add another print. And 1 second. Yes, N could be any any letter that you want. I'm just using N because it's a common one for ints. But it really matters, like this is the actual name or identifier of the integer we've created up here. If I were to create any name I wanted, we would then have to use that anywhere in place of N because N no longer exists. So this is the identifier, the type, and then assigning it a value. So same thing as if I had N in that spot, just now with the gibberish name. We can save that and take a look at it. We see it started out as 6, then got multiplied to 30. And you'll notice it's actually showing you where these prints are happening. This one, it was 6 at line 19. And then by the time we got to 23, that same line of code was printing out 30 because it was after we modified the value of it. So that's just some basic variables and stuff. Let's move on to integers. Not integers. We just talked about integers. Sorry, it's been a long day. Let's move on to arrays. So far we've just been using int. Let's take a look at another data type. Let's go with strings. We'll create an array of strings. So the array operator is the open and close square brackets. And we're now creating a string. We'll call this string array. And we've just declared it. We haven't set it to any values or anything yet. There's a lot of different ways you can assign different values to it. If we wanted to assign them after the game started at runtime, that would be done in the start or update. If we want to hard code it, that would be just setting it to a value right here. So we'll wait till runtime to start our array. We'll say our string array equals a new string array. And we'll say, let's have 4 in there. And we've just declared it to have 4 different strings inside that one variable. If we wanted to assign those strings to something else other than their default of empty, we can access each individual one by using the subscript operator, the array operator, just after the variable name. And we can specify which element we want. So big thing you guys might have forgotten, arrays always start out with 0. Programmers don't like to waste any data, so 0 is considered the very first element. They didn't want to waste it by starting out at 1. And then we can assign it a value. We'll go ahead and put a string in here. And we can go ahead and lay this out for each different string we want. So string 2, string 3, string 4, name is Justin. So we've now got all the actual strings in the array itself. If we want to read that data rather than just assigning it or something, well, we could go ahead and debug log each one of these. Debug.log.
Isn't there a way to like do them all at once instead of just one by one?
Yes, I will talk about that in a moment. I just want to show this the long way first, and then explain why it's better to do it the other way. So, filling the array out one by one, and then printing the array one by one. If we save this and take a look at what it's printing now, we'll see my name is Justin. So that's all right, but there's a few other ways we could add it if I didn't want individual print string or individual lines for each one of these and it to combine them. We can use what is called concatenation, and we could add a plus and copy these over again and lay it out a little bit differently so that it combines each one of them into one long string. The other part to this, if we wanted to, let's say, just save that and take a look now, it should just be one string rather than all different. My name is Justin. So concatenation can really come in handy when you have multiple things you want to put on one line, especially for like a debug object. The other part that can come into this is for loops. As you can see, printing out string array for accessing each individual one of these is kind of a pain. If we wanted to loop through all of these, there's, well, a function or a thing called loop. Yeah, keyword called loop. We'll be using a for loop. There's also for each loop, but we'll mostly be using for loop for this course. So for loop, there's a couple of different parts to it. You have to type the keyword for, and then inside the parentheses, you're defining 3 different things. The very first part happens before that first loop runs. Typically what you do here is create some kind of counter or integer, and we'll just be creating an integer so that we can change that, and then after it hits a certain condition, that's the second part, if that I is ever greater than or equal to the length of our array, then, sorry, this needs to be less than. This will only run the loop if this condition is true. So if this condition is ever false, meaning if it is equal to or greater than, it'll kick itself out of the loop and no longer loop any of the code. The specific code I'm talking about is the body of the loop. But before we type the body, there's this last third thing for the array. And this happens after it's looped, before it tries to check the condition again. So after each loop, we'll go ahead and say our counter counted up once. So once it loops through each one of the items in the array, because we start at 0, that's the first element, and go to the end, then we'll actually kick out of this for loop. We could add a debug log here, but we'll have that problem where it's printing on each one of the individual lines. So rather, even before, instead of doing that, I'm going to create another string and just call it temp. And our temp string for each of our loops, we'll go ahead and add on, so plus equals, the string array sub whatever our current loop is giving us. And it's complaining because I didn't assign it. We'll go ahead and say it's just an empty string, open and close quotes. And then after our loop's done, we can log this out. And we want to log out temp because that's what we were filling up in the array. So we'll save that. If we go ahead and play this, oh, of course it's not going to connect because I had the other one open. Fantastic. That's irritating. Let me try and close this real quick and get that to pop up again. Yep, kind of similar. When I'm going over the dictionaries, we'll take a look at, that'll be even more similar to the zoo registry because that's what that one is using. So close out of that. Let me try and open the script again and really hope it attaches because I wanted to show you guys some debugging options. Yay. All right, so debugging. You guys have been showing this several different times in Unity as well as in Unreal. Adding breakpoints, the best way you're going to be able to do it is just practicing yourself. Really, I would like you to just check out how your code is working, executing. You can add those breakpoints over in this left lighter gray bar. You can just click to add a breakpoint on a specific line. You do have to attach to Unity, so you get the debugging options up here and stuff for it to hit any of those breakpoints. And then as it tries to run this code, it can actually pause wherever you have that breakpoint. And then you can step through the code one line at a time. So if we do this and try and play, we see it's paused on this line, but you also have a lot more access to things other than just seeing what line it's currently on. You can actually check out the different values of things. String 0 is null, 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 null. We all know null means nothing. So as it runs through this line, if I wanted to even watch that string arrays category, we can click these little thumbtacks to tack them on. Comes in very handy if you want to watch the values. We have a couple of options to step the code. We have step into. If you're calling a function on that name, it'll go to that function's definition to the best of its ability. Step over keeps it in the current script that you're in and just goes to the next line that's going to be executed. Step out, kind of the opposite of the step into. If you're in a certain function, it can step out and see what it returns to from there. We'll go ahead and step over. We see it'll even highlight in red, indicating this string array element has changed. My name is Justin. So now we've got that array fully filled out. As we go down here, we could even watch a couple more things if we wanted to see what that temp is. And when you have these, you can actually drag them all around, things like that. Keep an eye out for what you want to watch at that time. So our temp is currently nothing. It just got set to a blank string. Let's watch our int I. And that's about it. And we can step through this. So I is currently 0. I was less than the length of the array. We can see it even evaluates that right here. So it's true, it's going to run this body, runs that body, gets to the end of the body. We see that it did add my to the temp. For loop again, since it's the loop, it loops back up to the top. I got changed to 1 after it did that increment. And I is still currently less than the length. So that's still true. Keeps looping. And we can watch it kind of fill out the array as it goes, accessing those different individual arrays from here. This comes in really handy to track down how code is working. So right now, as soon as I was changed to 4, that is no longer less than the length, because the length is 4. It's now equal to. So it failed this, kicked out of the for loop, and we're now just writing the string. If you want to just run the game again, you can click continue, and that allows it to run, return back to Unity, and allow it to hit it unless it hits another breakpoint. You can remove the breakpoints while it's still attached and everything like that, as well as any of these thumbtacks to what variables you are watching and stuff like that after a debugging session. All right. So this was just an example of filling out arrays themselves, arrays with loops. We could set this loop up if we wanted to go through the array backwards, say start at the end and count backwards. We could just change a couple of things about how it's looping. Instead of starting I out at 0, we could go ahead and start I out at the end of the array. So the length -1. Oops. And then if I is greater than or equal to 0, since we're counting down from 3, 2, 1, 0, then it would fail. We want -. So just changing that one line on 29. If we take a look at this, we'll see Justin is named my. So it printed all the strings in the reverse order. We're now iterating through that array backwards. Just something to keep in mind that we'll be looking at later in the class. All right, so that's all good. I'm gonna just comment all that out for now. For those of you that don't know, I just use a shortcut. I highlighted everything that I wanted, and then Control K and Control C, holding Control down, just tapping K and C will actually comment everything. Control KU, uncomment. Really useful shortcut if you just want to comment out a block of code. Next up, one thing we haven't talked about is dictionaries. So dictionaries is a data type. And while you may not have used dictionaries specifically, back in PGF1, you did end up writing what is called the book, that text adventure. You created something called Pages, where it held a specific title associated with a specific section of like the actual storyline. That's kind of similar to how dictionaries work. So as you're declaring a dictionary, it is a templated type. So that's where these little angle brackets come in. So dictionary, you're going to have to specify a type. Not just one type, 2 different types. Dictionaries work off pairing two things together. It can pair any type of key to any type of value. So the most common way you'll often see this is a string for the key for quick lookup. So we'll set our key type to string. And our value, let's just go ahead and set it up as an int. They do not have to be a string or an int. They can be any types that you want, just pairing two items together. The first type will be how you look up the item, and the second type will be the value of that item. So we've created a dictionary. Let's go ahead and give this a name. Let's see. I've been doing stats recently, and I kind of want to change it up. Let's go items. So items, and we can then assign this to a new dictionary. And while we have a dictionary, we need to add items to it similar to an array before we try and just access it or things like that. If we did try and, well, I'll go ahead and add an item first. Items dot add, and we can add a key and a value to it. So let's go ahead and add a key. Let's call this sword. And it has a value of 500. We'll consider this the value that we're using, just how much that item costs or something. So we've added that value. If we wanted to access that value and see it print out, we'll use that debug log to print. And we'll say, we'll print out sword as a value of, and actually get the value from the dictionary. Items, and we access this very similar to the array. We have to pass in a string for that key of that item that we want to look up. Well, that item we called sword. And I forgot to do a concatenation with a plus. And that should give us the value of the sword. We'll make sure this is all working and take a couple of, take a look at adding some more things to it. So we press forward, play. Sword has a value of 500. And I did a space before this. There we go. So that's all great, but we'd probably want to, if as we add each item, we'd have to type out an individual debug log again. We could create a couple of functions to help us out with this. Let's go ahead and create another function. This will be similar to the roll call function that you might have used for your, if you've done this experiment so far. When you're writing a function, there's several different things to take into account. The very first thing is, what is this function going to return? And if it returns nothing, then it can be a void type. I'm going to make a function that will add all the strings together in a nice, easy way to, no, I don't want to do that all in one. We'll take a look at that inside the function. So I guess we will have this function return nothing. And we'll call it just print items. we can then use one of those for loops to loop through each one of the items. There's a really handy way to do this using a for each loop. So I mentioned before we were just going to use the for loops, but I might as well bring this one into it. So for each loop specifically takes a collection of items. Since we're using a dictionary, it'll work perfect for it. The first part, you have to define what type of item is held per index, essentially. And for that, it's what is called a key value pair. Specifically, we're pairing a string with an int. And we'll just call this I, since that'll represent the item when we're inside the for loop. And then we can say in and specify what collection we're in. This is specifically in items. So for each loop, we'll look through items, and for each one of the items, it's going to fill out I, that value of the item, for us to use in the body. So if we want to print it out each one, debug.log, we'll go ahead and print out I's key, which is the name of that item. We'll add some formatting text. Has a value of, and then print out the value. And it is, oh, because I keep forgetting the concatenation. Got to have a plus between strings and ints. All right. So we have to make sure to call this function. So we just defined what this function does, but nowhere in our code were we using it. So let's say we do want to use this just up in start. Say print items. And when you are calling the function, you just need to use the function's name and specify the parameter list. If we did pass any information into it, it would have to go right here. But we left that parameters list empty, so there are no arguments being passed in. All right. Let's go ahead and check this out. Make sure that it is still printing this sword. So still says sword has a value of 500. And would have helped if I saved this and get rid of the other print so that it's now just using our function. Oh. And sword has a value of 500. We see that it is printing inside the print items, which is on line 50. So it's printing from there. And it's originally coming from our call up here. So this is more than just the exact print line. It's the entire call stack of how you got to that specific print. So that comes in real handy, especially when you're working with a state machine, figuring out which state caused an error or something like that, where the code is actually happening, not just where the error is being thrown. All right. Last up, we can add now any other thing like that. Snake bag. Bag is only 5. Shield. And we no longer have to worry about like spelling that same name correctly for an individual item lookup, because our for loop will just always print these items. But do watch out for the differences between capitalization. If you do go with one of the titles or one of the words being capitalized, just stick them all capitalized, or vice versa, so that you don't have any name clashing. Shields 20, goblet 50,000, helm it's going to be a cheap helm at 2, and makes you a great way to add a lot of data in a short amount of time. Loot, some magical loot that's going to be 10,000, and potion. We'll do 50 for potion. So we've now just added all these few lines up here. Instead of having to type out all those debug lines again, that's where this for each can really come in handy. Just simplifying it down, looping through each item, not having to care which ones you want or anything like that. And we should be able to print out all those different items in a clear, concise manner. All right. The other thing I want to point out is that instead of using add, if we were to add our sword just like this, using a key and the value, if we save this and try and run this, we see it still does get added. So that's just another syntax for how you can add a new key. You just have to specify the key and then set it to a value. It is recommended that you use the add, because that's a little bit more clear about what it's doing rather than this just assigning a value. Because if I have this twice up here, and the second time I'm doing 200, it's now no longer adding the value twice. Whereas if we have an add, it will only add that value. It'll let you know information like if that key already exists and you didn't mean to add it, things like that. You can get a lot more information out of this. You can also ask this dictionary if inside it contains a specific key. Let's say you're looking for a specific quest item or something in the inventory, and you wanted to find out if they had the goblet. You can find out and get a bool right back for if it contains the key or not. So we'll capture that return value from that. We'll call it bool, B for short, set it equal if the items list contains the key of goblet. And we'll debug.log quest complete, or have some sort of if statement to mark that on the screen, something like that. We'll make sure that this prints and shows if we have the key or not. And I think it will print first because we have that all above the actual call to print items. So that's the basics of a dictionary. Are there any questions about, oh, one thing I do want to point out, you notice up here how system collections generic is now white. It's because our dictionary is actually held in systems collections generic. So we wouldn't have access to dictionary if we did not have that using statement. It's going to complain and say, I don't know what the heck you're talking about. I don't know what a dictionary is. So until we tell it that this script will be using a specific namespace for the collections or generic collections, why didn't it show sort at 700? It showed as 200. Yes, because this is just an assignment right here. Nowhere did I ever set it to 700. This is not a plus equals or anything like that. While this is where it first was added to the list, right here, what that's doing is a direct assignment. We're saying we want to look up the sword key, and we're just going to set its value equal to 200. So this one, the way I'm doing just assignment right here, will not. If I wanted to add to the total, if I wanted to say items sub sword again, if I wanted to add, I could use one of the addition operators, plus equals or equals plus itself, things like that. If I wanted to increase it by 200, it's now going to be initially at 500, immediately set to 200, and then we're adding 200 to the 200. So that'll be 400. So keep in mind that this is just a way of accessing that specific item to have access to either set the value or get the value. And what you set it to is totally up to that second part after the equals sign. And we got a few more minutes here before I gotta head out, but we can go ahead and add another, we can change this up. If that was a definition of just string and int, for a dictionary, we'll go ahead and add another type of dictionary where we'll use a string for the key and string for the values as well. We'll call this book. Go ahead and assign it to a default constructor for a dictionary. And if we wanted to add items to this, I'm going to go ahead and make sure all this is commented out. And add some more things here. So our book. We'll go ahead and do the add like normal. We'll add. And our first one we'll use for chapter 1. Our second one will go ahead and actually contain all of chapter 1. So I don't want to waste too much time typing out a story there, but that should give you an idea, just a whole bunch of text. And then we'll go ahead and add another thing to the book. And this is, once again, just a way to join two different types together within a lookup table, essentially. Chapter 2. And This is the second chapter. So we've added two chapters to the book, and we could really name these chapters whatever. We'll say this chapter 1 instead is intro. Chapter 2 we'll call the second coming. We could then add another print item. We see that our current print items was just working on our items. So we'll call this print book. We'll create another function just like it. Print book. For each. And I'm going to use something a little bit cheap that's called var. And we'll say var a, let's go n. In book. And we'll print all those out. Debug log. And I'll keep it I. This actually just makes it a little bit simpler. So I can copy and paste that. Save that. After we've added a couple of pages to the book or chapters to the book, we can then print the book. Back in here, we can go ahead and play, and it should print out those different titles and values and stuff like that, so we can have an easy lookup. If we wanted to say just have a look at the second chapter, we could take a look directly at that. Debug.log, and we'll just say straight from book, we'll look up the second coming. So right at the end, it should just print, this is the second chapter again, twice. This is the second chapter, this is the second chapter, and debug log of that, yep. There it is. And we see that's how we can look up individual items from the array if we do need a specific item. Alrighty. So any last minute questions before I go ahead and close out of this, or?
Got nothing from me.
Alrighty. So as I mentioned, I will just go ahead and say that on here. For the week 1 content, I will push those due dates back till today, or well, let's go tomorrow. So I will be updating those due dates in a moment to give you guys an extra chance at that, since I was a little bit late on Monday. Yep. Alrighty then. I hope you enjoyed the session, and all right, can you hear me now? Alrighty. So yeah, the due dates for the assignments will be pushed back till Thursday instead of Monday or Tuesday. Yeah, they were due on Tuesday, but I'll push those back till Thursday. Alrighty, everyone. Have a good one and stay safe.